Okay, so this is Algebra 2, Module 9, Lesson 1, going over the answers for some of our evens. So number 2, we're supposed to be trying to find our values of 0. And so basically we say, well, if x equals 0, then it doesn't matter what's inside here. The whole denominator would equal 0. So that's an excluded value when x equals 0. The other ways that we'd do it is we'd take x plus 17, set it equal to 0, and solve. And so x can't equal negative 17 either, as negative 17 plus 17 would give me a 0, and anything divided by 0 is undefined. So those are the excluded values for 2. So on number 4, it says we want to write the expression with the denominator that's given to us. So this is going to be our goal. Let me go ahead and scoot this up. So we have to try to figure out how to make this denominator be that denominator. And so we're going to do this by, as we see here, we're going to divide out the 3, factor out the 3 here. And so that becomes 3 parentheses x minus 2 parentheses. And then you can divide 3 divided by 3 and simplify those out. So you're left with only this quantity here. All right. If you notice, we have a switched 2 and a negative x. So we have an x minus 2. What that means is I need a negative x, but a positive 2. And the only way I can flip these is by dividing and factoring out a negative 1. Now the thing about negative 1, a negative can be either in the numerator or in the denominator. It doesn't matter as long as there's only one of them. So you can have a positive divided by a negative, or a negative divided by a positive. So what they did is they divided out the negative in the denominator, but then just decided to rewrite it with the negative in the numerator. If you kept it in the denominator, technically that's fine. It's the same thing, but just making it pretty, trying to keep our denominator positive, they just put it in the numerator. So next we need to basically add this, and the only way you can include this into our denominator is by multiplying by the unit fraction of 1. And so that's exactly what they did here. They multiplied the numerator and the denominator by this same quantity here in order to have this entire thing in the denominator. So we did as much as we could with the denominator that we had, and then we multiplied by the unit factor to get what else we needed in the denominator in order to be able to create the desired denominator. Okay. So let's look at number 6. With our even numbers. So here we're supposed to simplify. So we say, okay, in my numerator I can divide out or factor out a negative 1. So that makes my x positive and my 8 positive, because if I was to redistribute the negative 1 back through, I would again get back to this original numerator. So that gives me a positive down here. And here they said, well, let's factor this. So I need factors of 8 that add to equal 9. And since they're adding, that means they're both going to be this sign here, which is positive. So factors of 8 that add to equal 9 would be 8 and 1. So they factored that trinomial, and then they said, hey, look, we got a unit fraction here that can simplify and aka cancel out, leaving me with a negative 1 in my numerator and an x plus 1 in my denominator. Okay, so let's look at number 8. So number 8 at first is kind of tricky, but then you have to remember, well, 1 can be a square, it can be a cube, it can be anything raised to its power that you want. It's kind of like a wild card where you can use it however you need to use it in terms of squares or cubed or such. So x to the 4th is a perfect square. x1 is technically a perfect square, and since this is subtraction, you have what's called the difference of two squares, which means they're going to be basically the same binomials, but they have an add and a subtract, so there's a difference. They're going to be subtracting. So I have x squared times x squared, which would give me my x to the 4th. I have 1 times 1, which would give me my 1 here, and 1 times negative 1 would give me my negative 1 here. But when I would go to do my inners and outers, I'd have positive x squared and a negative x squared, thus eliminating, simplifying out to 0, or just basically nothing. So you can actually factor the numerator of difference of two squares. Down here you can't, but we have an x squared plus 1 in the numerator, so we can in fact simplify those, leaving us with our single numerator binomial of x squared minus 2. So in this one here, factor of two squares is the key thing that you would need to look at in order to be able to simplify this problem. So let's look at number 10. So number 10 says denominator factors. We're trying to find our common factors basically between these two, so we can start adding without like denominators. So if I factored out a 5 here, I'd get 5 parentheses x minus 6 parentheses. So basically my factors for this one would be 5 and the difference of x and 6. Over here I can factor out a 7, and I'd get x again minus 6 over here. So they actually have a common factor of x minus 6. The difference is that this guy has a 5 and this guy has a 7. So if we were trying to make these to have the common denominator, I'd have to multiply this entire fraction by 7/7 to get my 7 down here in the denominator, unit fraction, and this one over here by 5/5, because this guy still needs a 5, this guy needs a 7. And that's what they have here. Our common denominators, our denominator factors were 5, 7, and x minus 6, and they both had that, but we only write it once. Because they only had it raised to the first power, this one had it to the first, and that one had it to the first. So all those combined gives me my common denominator that I need to make for both of them. All right, let's go ahead and turn the page. I'm going to factor both of these. So I need factors of 28 that subtract to equal -3, or basically 3, and your largest factor is going to be negative, same difference. So factors of 28, you can have like 1 times 28, 2 times 14, or 7 times 4, and the ones that can subtract to give you 3 is 7 times 4. So my factors are 7 and 4. I need a -3. So when I do my inners, I'd get -7. I do my outers, I'd get +4. That would then give me a -3x when I combine like terms. So over here, factors of 24 that subtract to equal -2. So we're going to have different signs, and the largest factor is going to be negative. So again, factors of 24, 1 times 24, 2 and 12. You can do 3 and 8, or 6 and 4. And so 6 and 4 have a difference of 2. Largest factor is going to be the winning sign here, which is negative. And so those are our factors. Now right off the bat, you can notice that this has a common factor of x plus 4. So these here are what you'd have to multiply the other fraction by in order to create that common denominator. So the different factors are x minus 7, x minus 6, and then the highest exponent, which is 1. On these guys, it doesn't matter, they have a common, it's okay. So this would be what you would multiply and should be your lowest common denominator to be able to combine like terms. Okay, number 14. Same basic thing, but first we're going to factor out. We said 5 can go into all of these, so we divide by 5. That gives me x squared minus 8x plus 12. So factors of 12 that add to equal -8. And since they add, that means both signs would be negative. So you get this here. On this one here, we're going to factor out a -7. So notice it's a -7. That means it's going to change the signs of everything in here. And so you get your factors down here. Note common factors. Note what you'd have to just multiply the other thing from. So list all of our factors, and thus our lowest common denominator would be this here. So I would have to multiply this denominator by a -7, and this one by a 5, so it'd be 5/5, and -7 -7ths. Okay, let's look at 16. So we have x squared minus 4 plus x squared minus 4, so it's a common denominator already. So that means we're just going to combine like terms in our numerator, which they did. And then I said, well, this is a difference of 2 squares. 4 can be square rooted, x squared can be square rooted, and it's a subtraction, which means you can have a plus and a minus. And then they said, okay, well, how do you change a negative to a positive? You factor out a -1, which means you change the sign of both of these inside of it, and then allows you to simplify this unit fraction right here, common factors right here, down to our answer. And then our excluded value is where x can't be, so that way you don't have a denominator of 0, and that would be when x, now down here, this comes back to our original, and this is a little tricky here. You don't just look here, because this was our original. X can't be positive or -2. Otherwise, none of this could have even happened to begin with, because it would have been undefined here to begin. Alright, so let's look at the next page. Okay. So number 18, we have subtraction. We do in fact have a common denominator, so that is nice. We can just put everything over that common denominator and combine like terms. And that's what they do in our numerator. So we get to here. right? So they say, okay, well, what can I factor out? I can factor out a 4 and get this quantity here, which x to the 4th is a perfect square. 1 can be a perfect square, and a negative, which gives me a difference. So I can write it as a difference of 2 squares. And then that gives me the same value in my numerator as in my denominator, allowing me to simplify those out. Now, here comes a kind of an interesting concept that this has no real solutions, so no values are excluded. Because if we were to drop our parentheses and do -1 to both sides, then you'd have x squared equals -1, which gives you an imaginary number. And that's why it has no real solutions. Okay, so let's look at number 20. So we have our problems here. So first and foremost, let's factor these. So I need factors of 4 that subtract to equal 3, and the largest factor is going to be positive. Okay, so it means they're going to be positive, negative. So what we end up is factors of 4, which is 4 and 1, that subtract to equal positive 3, so it's a -1 and a positive 4. Over here I need factors of 2 that add, so both sides are going to be the same, to equal 3, and thus, and technically -3, and they're both going to be negative. So I have factors of 2 are 2 and 1, both negative. If I do my inners, I'd get -1x. If I multiply my outers, I'd get -2x, and combined gives me my -3x, so I'm good there. So now I need to look for what they have in common. They have a -1 or an x minus 1 in common, but this guy is missing an x minus 2, and this guy is missing an x plus 4, or the sum of x and 4. So I'm going to multiply this entire thing by the unit fraction of the difference of x and 2 divided by the difference of x and 2. And over here I'm going to have the sum of x and 4 divided by the sum of x and 4. So that's what they did here. And you can see that's been multiplied to it. That's been multiplied to this one. So now we have a common denominator. And once we've done that, we can now, in this case, subtract my numerators. That means I have to distribute the -1 all the way through and combine like terms. So my x's simplify out, and I get -2 minus 4 gives me -6. So my excluded values are going to be +1, that would make that equal to 0, -4, that would make that equal to 0, and +2, which would make that equal to 0. Okay, let's look at 22. I'm going to look at that one and go, alright, well down here I have actually a difference of 2 squares because 9 is a perfect square, x squared is a perfect square, and 4 is a perfect square, and we have a difference, or basically a negative here. Over here I can say, well, could I factor out some other quantities here? Yes, I can factor out an x, and so let's see what happens. So 3x plus 2, 3x minus 2 is what my first denominator factors to. And when I pull up my x here, I get 3x plus 2, which is nice because I have one over here. So then I just had to say, what am I missing? So this one here needs to be multiplied by the unit factor of 3x minus 2 over 3x minus 2. And this one over here just needs to be multiplied by x. So let's do that, and that's what they did. That's what they did here. And now that we have a common denominator, I can now combine like terms in my numerator. My x's cancel, and I'm left with -2. And the values that x cannot be is 0. And then if I was set this equal to 0, I would -2 from both sides and divide by 3, which gives me a -2/3. This one, if I set equal to 0, I would add 2 to both sides and divide by 3, which gives me a +2/3, thus my excluded values. Alright, let's look at 24. On number 24, we have our 3 fractions that have 3 currently looking different denominators. If we notice, this one switched here. So I'm going to factor out a -1 and just put that negative and distribute it across to my numerator. So basically everything here gets zapped with a -1. So everything's going to change its sign from the original fraction. And so now I can see, okay, well, 2 of them have the x -3. This one has an x +3. So anything that doesn't have the other needs to be multiplied by it. And what they did here to make things simpler is, since these already have like denominators, they went ahead and combined them. So you'd have -x and -1 minus 2, which gives you -3. So they just went ahead and already combined those like fractions with like common denominators to make life easier. Then they went ahead and multiplied by the other denominator. That's what you have going on here, unit fraction. And then once they did that, they could combine like terms in our numerator, simplified, and then express their excluded values. Right. So on 26, we have our d represents the length of one lap. So we have 3d, and we have our miles per hour of 185 miles per hour. And then we have 5d for 5 laps at 200 miles per hour, because the remaining last laps out of the 8, which would give us 5, was at 200 miles per hour. So in order to find common denominators, they had to multiply all this one by 200 and all this one by 185. Now that they had a common denominator, they then can combine like terms and get your answer. Your initial setup here in our problem. So since this has a denominator of a over here and a b over here, you have to do the same thing where multiply this all by b, this all by a, in order to give us the common denominator of ab. Remember, b times a is the same thing as a times b. And then we can combine our numerators, but since they're not like terms, they're just going to stay that way. But since it's divided by, that means whenever you divide by a fraction, you have to do its reciprocal and flip it, basically, and then multiply. giving you this quantity here, and so our excluded values will be if A equals 0, or B equals 0, or negative B. These values do not occur because geometry links are always positive though. Right, so number 30, George wrote expressions that had the correct excluded values, but expressions are not equivalent to 2x minus 3. The correct expressions should have been as followed. And then again, because this would simplify, given me this equivalent value. So they're saying that yes, his denominators were accurate in terms of excluded values, but these won't simplify any further than what they are currently. So in order to get them to simplify, so all you're left with is 2x minus 3, then whatever is in the denominator would also need to be in the numerator in order for it to simplify out. And so that was the missing pieces that he needed on that one. Last but not least is 32. So sketch the graph. This expression has the excluded value, and that's why it has an opening at x equals -1. This can be shown on the graph by a hole at that one point, because it includes all the other points, but then it skips that one, so it's not part of the graph. It's not part of the line. All right, I hope this helped.